Dear students, in the last class, we have studied about the soil chemistry part 1. In that, we have studied about the lithosphere. So, what are the contents in the soil and how much depth of the lithosphere will be there and which are the plants that they grow and so on. Today, let us we study about the physical properties of the soil. So when I say the physical properties of the soil, some of the physical properties of the soil include texture, structure, bulk density, porosity, consistency in the soil, temperature, color and resistivity. These properties affect processes such as infiltration, erosion, nutrient cycling, and biological activity. Infiltration means it is a reduction in the filtration. The water will not readily pass through it. So the water remains in the soil. Erosion. So these are all the effect it affects for because of the other physical properties mentioned above. Now coming to the first one, the soil texture. The meaning of a texture is arrangement of the soil structure. The particles that make up soil are categorized into three groups by size of the particle. It includes sand, silt, and clay. Sand particles are largest and clay particles are smallest in size. Most soils are the combination of these three. The texture of the soil depends on the relative percentage of sand, silt, and clay. Example, we have clay loam structure of the soil. This clay loam structure of the soil has nearly equal particle size of sand, silt, and clay. That means this contains 33% of sand, 33% of silt, and 33% of clay. The sand has particle size of 2 to 0.05 millimeter. Silt has the particle size 0.05 to 0.002 millimeter and clay has the particle size less than 0.002 millimeter. There are 12 soil textural classes represented on the soil textural triangle. Here, the term clay or loam always have the same meaning. In some cases, we use the word loam. Of course, the clay is slightly different from the loam, but we can use it as loam also. It is contain little more percentage of the sand. Each texture corresponds to specific percentage of sand, silt, and clay. They are number 1, sand, only the sand. Next, we call it as loamy sand. Loamy sand contains the less percentage of clay, the loam means clay, and more percentage of sand. We have sandy loam. It means more percentage of sand and less percentage of loam or the clay. So like that, we have sandy clay loam, sandy clay, only the clay. We have clay loam, then we have only the loam. Next, silty clay loam, silty loam, and only the silt. So these are the 12 types of the soils we come across in India. Soil texture is an important soil characteristic that influences storm water infiltration rates. A clay soil is referred to as a fine textured soil, whereas the sandy soil is a coarse textured soil. The coarse textured means it is having the bigger sizes. So the next we have the clay is having the smaller particle sizes. Texture of the soil influences the numerous soil properties like drainage. So in some of the soils the water can move readily. That the movement of the water, that is drainage. Next, water holding capacity. Some soils have greater water holding capacity as the percentage of clay increases. In case of sandy soils, so that drainage will be fast. It will not hold the water. Next, another property, that is aeration. More the air content in the soil, so the growth of the plants will increase. Susceptibility to erosion. The next, organic matter content, pH, buffering capacity, and cation exchange capacity. These are all the various properties of the soil that are influenced by the texture of the soil. Water moves freely through sandy soils. As I have said, water moves freely through sandy soils than it does through clay soils. Clay soils have greater water holding capacity than the sandy soils. This is what I explained. Clay soils have a greater water holding capacity than sandy soils. Aeration in the soil produce healthy root growth and healthy crop. Sandy soils have good aeration than the clay soils. A soil with high percentage of silt and clay particles has greater erodibility than a sandy soil under the same conditions. Organic matter breaks down faster in sandy soils than in fine textured soils. It is because in case of sandy soil, more amount of the air is present. That air degrades this organic matter. The pH buffering and cation exchange capacity of the soil increases with percent clay and organic matter. Greater the percentage of the clay and organic matter, greater is the cation exchange capacity. Now coming to the another property, that is the soil structure. Soil structure is the arrangement of soil particles into small clumps called beds or aggregates. Sand, silt, clay, and even organic matter present in the soil bind together to form beds. The bed has a specific shape depending on the composition of the soil and conditions in which it is formed. The beds could be granular, it may be blocky, it may be columnar, it may be platy, it may be massive, like modeling clay, or single grained, like beach sand. Soil structure correlates to the pore space in the soil, which influences root growth, air and water movement. Another property of the soil is color of the soil. Color does not have a great effect on the behavior of soils. Darker soils absorb more light radiations. Color gives us clues about other soil properties. Soil color is influenced by the amount of proteins present in the soil. It results from the chemical and biological weathering. Soil color may be red, it may be brown, may be yellow, grey, black and even white. If the soil color is red to yellow, it is due to the presence of iron oxide. If it is dark brown to black in color, it is due to the presence of organic matter, sulfur and manganese minerals. Grey color of the soil is due to the reduced iron, that is Fe in +2 state. White color of the soil is due to the presence of oxides and carbonates of calcium, magnesium, zinc, aluminium, etc. Glauconite mineral is responsible for green color to the soil. Next, we take another property, that is bulk density of the soil. Particle density of the soil is around 2.6 to 2.75 grams per cc. It is lower for soils with high organic matter content. It is also high for soils with high iron oxide content. Earthworms size of the aggregates, that is the feces that produced from the earthworms because of the degradation. So based upon that, the bulk density of the soil also changes. It increases with increase in the number of earthworms and it decreases what you can say if the content of the earthworms are low. That's why we say the earthworm content soils are more fertile, more space in it, more aeration in it, more organic matter in it than the soil having very less number of earthworms. Next, we take another property, the porosity of the soil. Porosity of the soil is the open space occupied by either gases or water. In a medium textured soil, the total pore space is about 50% of the soil volume. Clay soils have smaller pores than the sandy soil. Pore size helps the plants and other organisms to access water and oxygen. Greater the porosity of the soil, the plants will go faster and faster because of holding water, the organic the minerals as well as air, and lastly the content of the content of the organic matter. Coming to the next, consistency of the soil. Consistency is the ability of the soil to stick to itself or to other objects. It is measured at three moisture conditions, that is air dry, moist and wet. Here consistency quality depends upon the clay content in the soil. It is useful in estimating the ability of soil to support buildings and roads. Next we take temperature of the soil. Soil has a temperature range between -20 to 60 degrees centigrade with a mean annual temperature from -10 to 26 degrees centigrade. Soil temperature regulates seed germination, breaking of seed dormancy, plant and root growth, and the availability of nutrients. So that's why the temperature plays a very vital role in developing the plants. Soil temperature decreases with increase in soil depth. Soil temperature can be raised by drying soils or the use of clear plastic mulches. Many times we have seen in the field, so the plants are covered above with the plastics, that is a green colored plastics known as mulches. That increases the temperature so that the germination becomes fast. Factors affecting soil temperature are water content, soil color, relief, that is slope, orientation and elevation, and soil cover, that is shading and insulation. So these are the factors that affect the soil temperature. Coming to the next one, resistivity of the soil. Soil resistivity is a measure of soil's ability to retard the conduction of an electric current. The electrical resistivity of the soil can affect the rate of galvanic corrosion of metallic structures in contact with the soil. Higher the moisture content and increased electrolyte concentration can lower resistivity and increase conductivity, thereby increasing the rate of corrosion. Soil resistivity values ranges from 1 to 10,000 ohm meter. Extreme resistivity values for saline soils and crystalline rocks. Now here these are the slides that shows whatever I have told you about the same thing. Here the first slide here I have showed about the composition of the soil, which we have already studied even in the first lecture. The soil contains about the 25% of the air, 25% of water, 45% of minerals, and then the 5% of organic component. Soil texture determines the amount and size of spaces between soil particles. This controls how quickly water moves through the soil profile and how much water the soil holds. That becomes the texture of the soil. So this is the triangle which I earlier told you. This triangle basically contains the percentage of clay, percentage of silt, and percentage of sand. And in India, we have 12 types of the soil. Coming to the one example, the sand, which is at the extreme left. That sand, it basically contains 90% of the sand, more than 90, the 90% of the sand and around 10% of the clay. If I take a silt which is at extremely right, it contains about 20% of the sand and 90% and around 85 to 90% of the silt. So this is how we can measure. If I take sandy clay, the sandy clay contains around 60, that is 60 minus 90, around 80. So around, we can say about the 35%, 35 to 40% of the sand and around 60% clay. That's why it is called sandy clay. Less percentage of sand, more percentage of clay. This is how this triangle helps to know what are the percentage of clay, silt and sand that is present in different types of the soils. This is a slide which shows the texture of the soil. So in this texture, the gravels, which is having the more size, so it is greater than 2 millimeter in size. Sand is having a range of 2 millimeter to 0.05 millimeters. Silt is having a size 0.05 millimeter to 0.002 millimeter. Clay is having lesser diameter than 0.002 millimeters. So this is about how the texture and various other aspects. This is a slide that shows the color to the soil. Suppose if the soil is blackish in color, so this blackish soil generally contains more of humus. That is the organic matter. The decomposed organic matter is called humus. And it may also contain the pyrite ores and iron sulfide ores. Suppose if the soil is reddish in color, it may contain the hematite ore. Like this, if it contains a gypsum, it is what you can say, light yellowish in color. If it contains dolomite, it is little whitish in color. The calcite, it contains whitish in color. So like this, the color of the soil depends upon the contents or the minerals that are present in the soil. Students, go through these things and try to learn about the content and various physical properties of the soil. Thank you.